Why is there something rather than nothing? That is the real question, not how the universe operates. Physicists are completely at ease with that one. Not its composition, not its age, not the events that transpired in the first split second following the Big Bang. Those are difficult questions, but they are the type of difficult that science knows how to approach. This one stands apart. This one resides right at the boundary of what it even means to pose a question. Most physicists tend to avoid it. They are happy to discuss the Big Bang, quantum fields, and the earliest microseconds of existence. But if you press them on why any of that exists in the first place, they will either defer to religion or quickly shift the topic. And I can see why. It is not a lack of courage. It is that the question appears to live just beyond the reach of scientific inquiry. I never considered that a sufficient reason to cease asking. I did not possess a neat solution. I want to be straightforward about that from the beginning. But I did possess something I believe is more valuable than a tidy answer. A method of engaging with the question that does not shy away, does not grasp for comforting platitudes, and does not ignore the complexity. And when you truly engage with it, when you pursue the implications of the question to their very end, you discover it is stranger and more fascinating than you initially imagined. Begin with nothing. When most people ask why there is something rather than nothing, they envision nothing as a kind of dark, vacant chamber, a silent emptiness. No material, no illumination, just an emptiness stretching in every direction. That is not nothing. That is space. And space is something. Space possesses geometry. It can be flat or warped. It expands. It contracts. Gravity is essentially the warping of space. Space has quantum fields running through every portion of it. Space complies with mathematical principles. The instant you imagine an empty room, you have already introduced a vast amount of structure, 3 dimensions, spatial connections, the potential for something to be in one place instead of another. Genuine nothing is nearly impossible to conceive. No space, no time, no fields, no forces, no mathematical laws, no logic, no potential. The issue is that every tool you would employ to think about nothing, your mind, language, logic, mathematics, is itself something. You cannot step outside of existence to inspect non-existence from an impartial viewpoint. The question asks you to ponder a state in which thinking would be impossible. Each time you attempt to define nothing precisely, it dissolves into contradiction. The question grows more challenging the more accurately you define its terms, which is the opposite of how most questions behave. This is where I want to go further, because there is a version of this question that is even more difficult than the one people typically ask. People ask, why is there matter? Why is there energy? Why did the Big Bang occur? And those are valid questions. But even if you respond to all of them, even if you offer a complete physical description of the first moment of the universe, an ideal depiction of how matter and energy arose from a quantum fluctuation or whatever it was, you still have not answered the more profound question. You have not clarified why the physical laws that generated all of that exist. Why those specific laws? Why does mathematics depict physical reality at all? Why is the universe the kind of place where electrons possess the charge they do? Where the speed of light is what it is? Where the constants of nature sit at the exact values required to produce atoms, chemistry, stars, planets, and life? The universe did not just need an initial condition. It required an operating system, a framework of rules. And those rules are, in a way, even more difficult to explain than the matter they govern. Because at least matter is something you can point to. Where did the laws originate? Now let me share something that modern physics has discovered which considerably reshapes this problem. The vacuum. Empty space is not empty. This is not a philosophical assertion. This is experimental reality. When you remove everything you can from a region of space, drain it, cool it, extract every particle, what stays behind is not nothing. What stays behind is the quantum vacuum. And the quantum vacuum is brimming with activity. Virtual particles constantly materialize and vanish, popping into existence for fleeting fractions of a second, taking energy from quantum uncertainty and giving it back before anyone can notice. The vacuum possesses energy. This is referred to as vacuum energy or zero-point energy, and it is measurable. It has observable consequences. The Casimir effect, for instance, a tiny but genuine force between two uncharged metal plates positioned very close together in a vacuum, exists because of the quantum vacuum's energy. The vacuum fluctuates. It is never genuinely still. It cannot be genuinely still because quantum mechanics forbids a state of perfect emptiness at perfect rest. And this matters enormously for the question of why anything exists, because it implies that true, perfect, total nothing may be physically unstable. That given the principles of quantum mechanics, something is, in a sense, more natural than nothing. A perfect vacuum, if such a thing could exist, would be prone to fluctuating into something which raises the obvious question of where the principles of quantum mechanics that make nothing unstable originated. But it is still a profound shift. The universe's existence might not demand a special explanation. Non-existence might be the thing that demands explaining. There is another asymmetry embedded in the early universe that I want to highlight because it is one of the most peculiar facts in all of physics. When the Big Bang occurred, the energy of that event should have generated matter and antimatter in perfectly equal quantities. Matter and antimatter are mirror reflections of each other. Identical mass, opposite charge. And when they meet, they destroy each other entirely. They convert fully into energy, leaving nothing behind. If the Big Bang had generated perfectly equal quantities, which is what the symmetry of physical laws predicts, the entire universe would have annihilated itself in the first second. Every particle of matter would have discovered its antimatter counterpart. Everything would have become light. And then that light would have dispersed through an empty, expanding void forever. No atoms, no stars, no planets, no you. Something shattered the symmetry. We do not fully understand what. For every billion antimatter particles, there were 1,000,000,001 matter particles. A tiny surplus. An imbalance so slight it is almost negligible. And yet it is everything. Because when the annihilation was complete, that 1 in a billion surplus endured. All the matter in the observable universe, every galaxy, every star, every planet, every atom in your body is the leftover remnant of that asymmetry. You are the remains, the fragments from a nearly ideal annihilation that occurred 13 billion years ago. We do not know why the asymmetry exists. We have possibilities. We have hypotheses. But this is genuinely unresolved. The fact that anything exists, that you exist, relies on a broken symmetry whose origin we cannot fully clarify. That is not a gap in the textbook that will be resolved next year. That is an open wound in physics. Now, I want to explain why I never found the common answers satisfying. When people push this question, why does anything exist? They tend to gravitate toward three things: God, the multiverse, or the anthropic principle. And I was doubtful of all three. Not because they are necessarily incorrect, but because of what they do to the inquiry. The God answer, regardless of what you think of its validity, functions as a conversation stopper. You have explained existence by appealing to a being whose own existence is equally unexplained. You have moved the question back one step without resolving it. If the universe needs an explanation, so does whatever created it. You have not solved the problem. You have relabeled it. The multiverse does something comparable. The idea that our universe is one of a vast or infinite number of universes, each with distinct laws and constants. It is a legitimate scientific hypothesis, not merely speculation, but as a response to why anything exists at all, it falls into the same snare. If there is a multiverse, where did that originate? What are the laws governing the process that produces universes? You have enlarged the thing that needs explaining, not explained it. And the anthropic principle, this one is the most seductive and the most hollow. The anthropic principle states that the universe has the characteristics it has because if it did not, we would not be here to observe it. It is logically sound. It is also, I would argue, nearly pointless as an explanation. Naturally, we observe a universe compatible with our existence. We could not observe anything else. But that tells you nothing about why a universe compatible with our existence exists in the first place. It tells you why we perceive what we perceive. It does not address why there is something to perceive. It responds to the wrong question with complete confidence. And people mistake that confidence for profundity. Now, let me discuss symmetry breaking because it is the physics concept that I believe comes closest to the actual structure of this problem. The universe we have is not the only universe that could have existed given the starting conditions. In the extremely early universe, fractions of a second after the Big Bang, at temperatures and densities we can barely compute, the four fundamental forces were likely unified: gravity, electromagnetism, the strong nuclear force, the weak nuclear force, one symmetry, a system with multiple possible outcomes. As the universe cooled, that symmetry shattered. The forces separated, and the specific manner in which they broke, the specific values the constants settled into, produced the universe we have. But it could have broken differently. The constants could have settled into different values. A universe where the strong nuclear force is slightly weaker would produce no stable atoms. A universe where gravity is slightly stronger would collapse before stars can form. A universe where the cosmological constant is slightly larger would expand so rapidly that matter never gathers together. The vast majority of possible universes, possible combinations of constants and laws, produce nothing of interest. No structure, no chemistry, no complexity. We happen to be in one of the ones that succeeded. And we do not know if that is a miracle, a selection effect, a result of a multiverse, or something we lack concepts for yet. Here is what I believe is the most honest statement that can be made about this question. I do not know. And I mean that in the most precise scientific sense, not as a shrug, not as a placeholder for future discovery, but as a genuine acknowledgement of the current state of our knowledge. This is a question where the honest answer is that we are at the boundary of what our instruments can access. Pretending otherwise, dressing up one of the comfortable answers and offering it as established is a form of falsehood. And I never had much tolerance for that kind of falsehood, even when it was wrapped in very sophisticated mathematics. But not knowing is not the same as the question being without meaning. That is the point I want to make clear. The question, why does anything exist, is not a confused question or an improperly formed one. It is pointing at something genuine. It is the most fundamental question you can pose about reality. And the fact that it defies simple answers is a strength, not a flaw. It means we are asking something genuinely difficult, not something we neglected to search for. And here is the thing I keep returning to, the thing I find truly remarkable. The universe, whatever it is, however it came to be, organized itself over 13 billion years into configurations complex enough to inquire why it exists. Matter became atoms. Atoms became molecules. Molecules became chemistry. Chemistry became life. Life became nervous systems. Nervous systems became minds, and minds became capable of observing the cosmos and finding it perplexing. The universe produced out of its own material the capacity to wonder about itself. That is not an answer to why anything exists, but it is not insignificant either. The question itself, your capacity to ask it, to sense its weight, to be genuinely disturbed by the possibility that there might be no answer. That is part of the narrative of what the universe is, what it does, what it is capable of generating. The universe may not have a reason in the way humans use that word. Reasons require minds. And minds emerged billions of years after the universe began, but it has a structure. It has laws. It has a specific, finely adjusted set of properties drawn from a vast array of possible properties, most of which led to nothing. That specificity, that particularity, is what makes the question so persistent. If the universe were just any random arrangement of matter and energy, the question would not be so pressing. But it is this one. These laws, these constants, this specific outcome out of all the possible ones. Stay curious. Stay honest. Do not fill the silence with comfortable noise. That was my response. Not a theory, but a stance, a way of confronting the question without hesitation and without pretense. The question, why does anything exist, is not the end of physics. It is where physics begins. Every equation we have ever written, every experiment we have ever performed, every constant we have ever measured, all of it is an attempt to comprehend a universe whose existence we cannot yet clarify. We are inside the thing we are trying to understand, working from the inside with tools composed of the same material as the mystery. That is the reality. And I find that genuinely, without any performance, one of the most extraordinary things I can conceive.